Hi, it's time to review some more random videos found on the internet to see if they have any electronic merit. Coming up next. Greetings, the Astro30 here yet again. I found another video while searching for something else on the internet. I think I was looking for a 3-watt amplifier schematic, and I came across this video. Let's have a look.
Oh, what horrible music. Anyway, BD139, its pinout is emitter collector bass from left to right. So it's bending up the bass pin. Oh, really should use pliers, mate. Bending the collector pin. Okay. Oh, the PMP, complementary pair to that, BD140, same pinout. So what's he going to do? He's bending the bass pin. Okay, he's going to join collector of the first transistor to the base of the second transistor. Another BD139. Bending the emitter lead. Okay. Bending the emitter lead of the PMP. This looks like a push-pull amplifier with a common emitter output stage. Interesting. This might not be so bad. Piece of wire going between collector of the PMP and the emitter of the first transistor. 47K. We're soldering that from the emitter junction to the base of the first NPN transistor. Okay, 560 ohm. That appears to be connected to our base of the last transistor and going nowhere at the moment. 330 microfarad being connected through that resistor on the positive to the emitter junction. Okay, a rectifier diode being soldered between the collector base junction of the first two transistors. Another one soldered in series with. And it appears to be wired to the base of the third transistor. Okay. Positive goes in the collector of the last transistor and negative into the emitter of the first transistor. Okay. Yeah, of course you're going to wire the speaker to positive. But interestingly, if I'm thinking how the circuit does work, it's actually wired off the capacitor after the emitter. So it may be going through a blocking capacitor, so that would be okay topology, I suppose. Got an input capacitor. Interesting to see a circuit like this on YouTube using two capacitors. Well done. Oh, they actually show a circuit diagram. Yay! Not long enough though, but from what I saw, the topology wasn't that bad. We'll look at it a little bit more in depth in a moment. God, this music's annoying. Oh, that is so distorted. Maybe because it's being overdriven. Yeah, that sounds terrible. Oh, I can sort of work out what the track's supposed to be, but so much distortion there. High watt battery. Yeah, okay, cool. Oh.
Penis. And here's your the schematic. It is actually a basic stock standard amplifier output stage. We've got a VAS down here, or voltage amplification stage. We've got a self-biasing network, a fixed resistor up here, which goes between the two bases of these two output devices. Yes, the speaker is connected to the positive rail, but it wouldn't really matter, as we explored another circuit that I looked at earlier, that 300 milliwatt amplifier. It wouldn't really matter if this was connected to the positive or the negative. It's still going to see some form of DC, but the amount of DC current flow going through the speakers is in the order of microamps. It's really negligible. We do have a blocking capacitor here, although if we were to swap from the positive rail to the negative rail for the speaker reference, we would just simply reverse the polarity of that capacitor going onto the output. We've got DC feedback going back to the first transistor, the BAS, to bias it on, and the input signal comes here. It's pretty much basically similar to an output stage of a stock standard power amplifier. Because this is running on a single 9 volt supply, this would be classed as a class A output stage, so there'd be half the supply voltage here, 4.5 volts. But because these are BD139 and 140 transistors respectively, this voltage could be severely higher than plus 9 volts. It could be plus 20 volts, even as close to, I think, about plus 30 volts. I can't remember offhand what the collector to emitter voltage rating of those transistors are. I think it's 35 volt. I'd have to look that up. Anyhow, so what we're going to do is we're going to build this up on a bit of breadboard and test it. Why not? The distortion that they were experiencing is probably because they're overdriving the input here. The other thing that we can do with this circuit is we can actually add an input stage to this, a long tail pair with two BC556 transistors, for instance. The VAS base would be driven off of the collector of the first input transistor. Then we can have negative feedback and a gain set resistor going to ground on the second input transistor, like a standard power amplifier, and yeah, actually control its gain. As it is, it'll work, but that's another thing I might explore in this video, is putting an input stage on it. Why? Well, because we can. It's an experimentation video. But for now, I'm going to build it up as it is, and we're going to see what power we get on the output, both in this configuration, going to positive, and in the other configuration, going to ground. So, let's get cracking. Yippee-ki-yay, mother... And of course, watching my re-edited video back again, I realised I did it again like a similar circuit I reviewed before. I connected this resistor to the wrong place. I actually connected it to the positive rail instead of connecting it to this capacitor speaker junction here, as is shown in their schematic. So I've corrected that now, so that's the way it is. This effectively is basically bootstrapping this output stage network, but this resistor 560 ohm can simply go straight up to the positive, and we can actually remove the speaker from the positive connection and put it down to the ground connection down here. Right, well, I've been to Dingo Piss Creek where the beer is expensive and indeed tastes like dingo piss. Anyhow, I've got the circuit built and I'm about to test it. I just want to do a blurt test for now. Right, you guys can look at the scope. I'll hook the power up. Indeed, we are. However, there is one issue. Those transistors are getting red hot. So I'm going to actually reconfigure the circuit now. Move that 560 ohm resistor directly to the positive rail and take the speaker from the capacitor to ground instead, because I really do not like the idea of DC running through the speaker. Well, with connecting the 560 ohm resistor to the positive rail and swapping the speaker connection around, and also connecting the base of the output NPN transistor to the actual biasing network, does tend to help. The transistors are no longer getting hot, but we are getting a signal, albeit it appears to be ringing, and that's as much as we get out of it, which is no more than half a volt. Because as soon as I start increasing the oscillator, it's actually clipping on the positive going cycle and we're at 100% on the laptop, so I'll just make sure. It will not go any further than that. So as an amplifier, this is about as useful as tits on a ball. So this is not functioning correctly at all. Got a 100 picofarad across the base and collector junctions of that first transistor. It does not appear to have made any difference. And we're still clipping asymmetrically. And we're not getting any more than half a volt out of the bloody thing. Yeah, well, that looks a little bit more respectable. I've made it about as far as 4.4 volt. It is jumping up and down a bit. So what I did is I pulled the whole circuit apart, threw the breadboard across the room, cracked the shits, and then went back to Dingo Piss Creek, got some more expensive beer that still tastes like dingo piss, and came back and rebuilt it. The change I've got now is I've got a BC546 as my voltage amplification transistor, which is fine, with a Miller cap across it because it's not very stable. So the 100 picofarad is going between the base and collector, and I basically pulled the transistors out and then I mounted it in a row, including the diode, so it wasn't all over the place, so it made more logical sense. This is clipped to a piece of aluminium, this BD139, because it does get red hot, but that would make sense. Considering the 560 ohm doesn't go to the output capacitor, it actually goes to the positive rail. I changed the 470 microfarad output, I changed the 330 microfarad capacitor on the output to a 100. It really doesn't make that much difference in the grand scheme of things at the moment. Pardon. And yeah, it's working fine. That that 140 is not getting remotely near anywhere as hot as the BD139 is, but it does need to be on a heatsink. But again, as I said, it makes perfect sense. So with 4.4 odd volt peak to peak coming out, we're getting roughly close to a watt. So what did I say? It was 4.4 volt peak to peak. Well, we know what that is divided by 2. Multiplied that by itself equals, well, okay, divided by 8 ohms, 600 milliwatt, thereabouts, which is a lot better than what I was getting initially. However, the output's not very stable, but that could be because it's running on a 9 volt DC plug pack adapter off of a switch mode power supply. Okay, I'm kind of running out of room on the desk. I'll hook up the supply now that the speaker's in on the circuit. Oh yeah, listen to that high frequency whistle. Okay, so I'm going to turn the volume down. Apart from that high frequency whistle, it doesn't sound too bad.
Baby, you give me ice and fire. You're giving me wind and rain. You're some kind of butterfly. Baby, you give me midnight. You whip up my appetite.
Okay, that whistle is kind of annoying. So, I'm going to connect up to my flat 9 volt battery. Should have bought another one. Still got a buzz there, but there's no high frequency whistle. Yeah, I don't think there's enough current in that battery. I want to try something. No. Sounds like it's gonna explode. Well, would you look at that? The output's more stable now. Why? Well, it helps to connect the input ground to where all the signal grounds are rather than at the negative of that capacitor. Because if I move my signal ground from there to the capacitor, got the annoying whistle or oscillation, switch that back to where the signal grounds are, bam, it's much more stable. Well, at least it's a lot better. It doesn't sound all that great though. It's lacking in bass, but that could be that input capacitor could be too low of a value. I've only got a 2.2 microfarad in there instead of a 22. I didn't have a spare 22. I've got a 47 somewhere, but yeah, I don't think it's really necessary for this at the moment. Yeah, well, at least that annoying whistle's gone. I mean, it's still prominent on the speaker, you can hear it, but it's not as bad as it was. So yeah, that whistle is still there. But it's right up in the frequency range there, almost at 20 Hertz. I mean 20 kilohertz. Yeah, this DC adapter is crap. Well, for audio circuits. Anyhow, so I'll go track not available. Sounds a bit better now though. Okay, moving on. Dingo Piss Creek sounds like a great option right now. Anyway, I've redrawn the schematic as I have got it laid out. Got a 9 volt coming in over here through a 470 microfarad bulk capacitor, smoothing capacitor. That gives us our output stage of the BD139, BD140 connected emitter to emitter. The 330 microfarad capacitor going, the positive plate going to the emitters, negative going to the speaker. Now, be sure to get this capacitor the correct way around. If you put this the other way around, this capacitor will get really, really hot when it's connected to the load. So it is important that the positive goes towards the emitters. I already found that out the hard way. So not much has changed in the circuit except there's the addition of this 10K resistor down here. So this is actually balancing the input transistor here, which is now a BC546. It doesn't need to be a BD139. That's just overkill. Unless you were to up the voltage a bit more, you might want to change it back. The other addition is this millicapacitor, which is 100 picofarad. I haven't written the value, but it just stabilizes the transistor. Input comes through here, that's supposed to be a 2.2 microfarad. I didn't like that either. Geez, I'm getting slack. Now, and I also buggered off the bootstrapping and routed this 560 ohm resistor directly to positive. Now, would this circuit benefit or even work with a long tail power input stage? Well, it should do. I can't see any reason why not. What benefit will we get? Well, we'll be able to control the gain a little easier, more to the point, and probably find that this 10K resistor will no longer be needed because, well, there's going to be a resistor there anyway, but it's going to be smaller. That's going to be connected to the collector of the input transistor, and this capacitor will move to the input. So the next stage would be to, well, try it. Well, apart from now there's a bunch of crap all over the desk, in a word, yes. And with tuning a few resistor values here and there, I am now managing to get 5 volt healthily out of it. Ignore that trim pot. I had that on the board because I was adjusting resistor values around to get the desired result that I wanted. So at our current voltage, which is now 2.5 peak, multiplied that by itself, equals that now divided by our load, we're getting closer to 781 milliwatts of output power. Not quite a watt, but if you up the voltage to 12, it probably would get close to it. So yeah, that's working. The transistor is going to get hot though, so I'm now going to kill the tone so I'm not driving the amplifier so hard now. With the speaker connected, there's still that slight whistle there coming from the power supply, but all I can hear is like a bit of mains hum. So now sounds a little bit better. Let's try playing a track now. Sounds a bit better actually. Does go to quite loud levels without distortion, so winner chicken dinner. Gotta be careful that that output lead does not come into contact with that metal bracket, because that connects it directly to the collector of the BD139, which connects it directly to the positive rail. Anyhow, shit. Alright, so here's a finalised schematic. The changes I've made, it's a 330 ohm here in the biasing network. We've got a 1K here on the collector of the first transistor of the long tail pair, and a 1K3 on the emitter junctions, and that gives us a reasonably balanced input stage and gives us around about the 5 volt peak to peak mark out before clipping. Nothing else has changed. We now have a 22K and a 1K resistor going to ground. That capacitor's not there because I couldn't get an output signal with that value capacitor there. I will try an experiment in a minute and see if I can get an output with a capacitor there, but for now that's just not really in circuit. It's the resistor goes down straight down to ground, and that gives us a gain of 23. So I need to now calculate what the input sensitivity is at that gain, knowing what my output voltage is. So if we divide our output peak to peak voltage of 5 by the gain, that gives us roughly an input sensitivity of 217 millivolts. I'll say the 200 millivolt mark for full output, which is perfectly fine. So I know that this is a complete and utter redesign of the original circuit that I reviewed, albeit it did work. I couldn't get it to work in the original configuration of having the 560 ohm going straight to the speaker, or I may have mucked up my wiring or something, I don't know, but in this configuration it works quite well. And having a long tail pair here now allows us A, to control the gain, and B, also to control common mode noise. So all in all, it's a success. Now I don't know if you increase this voltage here, whether this value of a resistor would have to change. That'd be up to experimentation, which I am not going to get into because I'm not really particularly interested at the moment in this circuit. I was just testing a theory to see if it worked, and it worked. I'm going to play with this now and see if I can get a capacitor to work in circuit. Well, no, it doesn't, but that's fine. So I'm going to drop the output voltage, go right down to 20 Hertz, and we're starting to roll off really severe now. 60 Hertz, 40 Hertz, and then it just buggers off. So what's interesting to me is as I sweep the control up, Gets higher in voltage and it drops back down again. Then towards 1 kilohertz it rolls off and then starts to increase back up to 2 kilohertz range. That is really odd. Please excuse the crudity of my graph here, but this is my mapped out frequency response of this amplifier, which is all over the place. On the y-axis we got the voltage peak to peak output, and on the x-axis we got the 20 to 16,000 kilohertz. That's about as far as I went. Around the 20 hertz mark we're around about 0.6 of a volt. By 100 we've jumped up to 4 point something, 3.9 I think it was. By 500 we're now shooting up well over 5 volt. Then by 1000 we've dropped back down to around 2 volt. By 2000 we've come back up to 3.6, and then it remains stable up to about 8000 where it drops down to about 3.5, and then by 16,000 it shoots back up just a little over 5. So it has a weird frequency response, and I had to turn the circuit off now because that output transistor was getting red hot because I was doing a lot of testing, but it doesn't have a heatsink, but it does need one. The only reason I can think that the frequency response is all over the place is because of the choice of capacitors here. Like the output capacitor could be having some effect on it, so can the input capacitor. So it's kind of important that you choose your capacitors wisely. However, in its configuration sound test wise, I can't hear a difference in the frequency response. But yeah, it's all over the place. So it might be more stable if there was a capacitor on the gain resistor going to ground. But I did try putting a 47 microfarad in there and it still did not give me an output. So anyway, all in all, I reckon that's a good little amplifier apart from its frequency response. However, this video has gone on long enough. I think you'll get the point now. It's close to a 1 watt amplifier running at 9 volt. Anyway, I'm going to leave this here. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you can become a Patreon member for as little as $1 a month. Would like some more Patreons, guys. Anyhow, this is the Astro 30 saying, see ya. Winner, winner, chicken dinner.